So I'm going to give you an overview of the South African Astronomical Observatory. I'm, as of very, very recently, the managing director. I've been acting director the last 10 months or so. But it's my pleasure to give this talk on behalf of SAO to just give you an idea of some of the things that we do here. Let's just get this going. So SAO has a long history of doing astronomy and doing astronomical research. We are more than 200 years old now, founded in 1820 as the Royal Observatory at the Cape of Good Hope. We, in addition to doing astronomical research, we also provide telescopes and provide data for astronomers across the country and around the world to do their research. So we have our two sites, our Sutherland site, where the telescopes are based, and then our site here where we are today, which was the original Royal Observatory here in Cape Town. Our observatory here, the main building they started construction in 1824-25, so we're now 200 years old in terms of the building as well. In addition to providing the data and doing research ourselves, we're very involved in teaching and training and building up the next generation of both scientists and engineers. And we have a strong engineering department and instrumentation division, which is involved in continually renewing our telescopes, building new instruments, and also doing development work, trying to come up with novel ways of doing things, some of which would then also hopefully contribute to other areas outside of astronomy. And throughout what we do, we consider it very important to share this with the broader society, with the community. And so we have a number of education and programs to reach school children, the teachers at schools, but also just the general public. So I'll touch on all of these things as we go along. Our telescopes are located in Sutherland, which is about 370 kilometers from here, in the Karoo area, which is a semi-arid, very dry area of the country. And the observatory there was started in the 1970s when the lights from Cape Town just became too bright to really do meaningful science from here. So here you can see a map of South Africa at night, and you can see the lights from Cape Town. And Sutherland is located in this very dark region. It's also protected by law, so any developments in the area have to take care of both minimizing light pollution and minimizing radio interference, because we also have the Meerkat radio telescope and square kilometer array site further north here. So this is Sutherland and this is Meerkat. I'll talk a little bit more about Meerkat later. So that's run by the South African Radio Astronomy Observatory, and as many of you may know, is the most powerful radio telescope in the world at the moment. So our site is very dark, and it's actually in this paper from 2022 comes out as the 4th darkest observatory site in the world. So we take pride in that dark sky, that beautiful sky, and try to protect it. So this is just an overview of the telescopes. This is already out of date, as some of you may notice that Prime is missing from this picture. So this is drone footage from a few years ago. Prime's over here, a little bit further that way. There we go. Yeah, so we've got SALT in the background. This is the Southern African Large Telescope, which is our flagship facility. We've got the 3 original SAO domes and the 1.9 meter telescope. So these ones are fully owned by SAO. And then there are a number of other telescopes that are either co-hosted or partnered facilities with international partners from around the world. There are also some sort of facilities for observing lightning sprites and other sort of things like that. So not all purely astronomy. So this is just a list of the telescopes there. We've got SALT, the 3 SAO telescopes, which are a 1.9 meter, a 1 meter, and a new 1 meter called Lesedi. And then Prime. So this is obviously the subject of this week's conference and opening on Friday. a 1.8 meter wide field near infrared telescope. Another relatively new one is Atlas, which is a 50 centimeter telescope used for searching for asteroids and other transients. So it's discovered quite a few comets and asteroids already. Meerlicht is also a relatively new 65 centimeter telescope that is trained on exactly the same patch of sky that the Meerkat radio telescope points at. So there's always simultaneous observations between Meerlicht in the optical and Meerkat, the radio telescope, as far as possible, at least. And then we have a number of other telescopes. The IRSF is also a Japanese partnership, that's been going since 2000. There's a Korean partnership, German, more American, Russian, Polish, so quite a wide range. SALT, our Southern African Large Telescope, is an 11-meter mirror made up of 91 segments. Each segment is about 1 meter across. And so I hope many of you will get to see this on Friday. It's a very impressive large telescope and still the largest in the Southern Hemisphere until the ELTs take over. It's a partnership between South Africa and 7 other international partners. South Africa has the largest share. We're contributing about 50% of the operating costs, and so we get about 50% of the observing time. But our international partners are integral to it, and it wouldn't have been possible without everyone involved. SALT has been doing regular science since 2011, so coming up to 15 years or so. It's a fully Q-scheduled telescope, which means we have a team of astronomers based here at SAO that does the observations on behalf of all the partners. So partners around the world submit their proposals twice a year, get allocated their time, and then the proposals go into a queue, which our team of SALT astronomers then does the observations of. So these are the partners: University of Wisconsin, Dartmouth College, Rutgers University in the US, and the American Museum of Natural History, and then IUCA in India, and a group, the Polish Nicholas Copernicus Astronomical Center, and then a group of UK universities. So these are all relatively, the UK universities are relatively small partners, and some of them are now finding it difficult to continue with changes in the funding model in the UK. But we hope we'll continue to have involvement from the UK going forward. The instrumentation on SALT, I've just included an overview in case some of you are not very familiar with SALT. So it's mainly a spectroscopic telescope. We have SALTICAM, which is the acquisition camera, and also has some very high speed modes, slot mode and frame transfer mode for imaging. And then the Robert Stovey spectrograph is the workhorse instrument on SALT. It's quite a, Swiss Army knife type instrument that can do many things. But the main modes are long slit and multi-object spectroscopy. Recently, we've added an integral field unit on the Robert Stovey spectrograph, which I'll talk about in a minute. It can also do polarimetry and also can do high-speed spectroscopy. Then there's a high-resolution spectrograph that has 3 different modes, low, medium, and high resolution. And it also has a high stability mode that we're continually developing, at least developing the calibration for this high stability mode for radial velocity exoplanet follow-up. So at the moment, we're busy developing a laser frequency comb to do that wavelength calibration. But it also already has both thorium, argon, and an iodine cell, and can do radial velocity measurements. The latest addition to SALT is called the NIRWALS, Near Infrared Washburn Astronomical Laboratory Spectrograph, built by the University of Wisconsin. And this is a near infrared spectrograph, an integral field unit. It has a bundle of fibers, and it's also medium resolution. Let's go to the next one. We're still busy with characterizing the NIRWALS data and trying to improve on the data reduction mechanism so that we can get the most out of it. And the detector is unfortunately not very good. So we're struggling a little bit with that, but hopefully we'd be able to go into regular science with NIRWALS soon. Then the slit mask integral field unit for RSS is one of the latest developments. So this is basically enabling our standard spectrograph, the RSS, to do not just long slit or a mask multi-object spectroscopy, but to have a bundle of fibers and do integral field spectroscopy by very cleverly fitting these fibers into one of our standard slit masks. So it can slot into the slit magazine as if it was a normal long slit, but it's doing this spatially resolved spectroscopy through a bundle of fibers like this. And then this is the laser frequency comb that we're developing for the high resolution spectrograph. You can see a bit more on that here. So this was first light last year. This is a collaboration with Heriot-Watt University in the UK, or in Scotland. So here you can see the light from the star, the sort of top of each of these, and then the light from the laser frequency comb is very finely spaced lines that you can use for wavelength calibration in the other fiber. So this development has been going for a few years and it's going very well. And we're still working on the software, really. That's the main thing remaining to take this into regular operations. So the SAO telescopes, the other 3 telescopes fully owned by SAO, are a 1.9 meter. This was originally the Radcliffe telescope it was built in Pretoria, further north, and then moved down to the Sutherland Observatory in the 1970s. But the mirror was already ground before the Second World War, so it's quite an old telescope. But it's gone through continuous upgrades and is now fully remotely operable. And I'll talk a little bit more about how we continually striving to make our observatory, to take it into the modern era with remote operations and sort of intelligent use of software. It has a low to medium resolution spectrograph called Sputnik. It does polarimetry as well and high-speed imaging with the shock camera. Then there's Lesedi. This is a 1 meter telescope, also relatively new, 2019. It also has a low resolution spectrograph called Makori and a wide field imager called Sibonise. And that Lesedi is regularly operated fully remotely and robotically, with sort of responding to transient alerts as they come in. The older 1 meter telescope has a shock camera as well, a high-speed imager, and in a few months' time we'll host Wallop, which is a large polarimeter, and that'll be operating or doing a polarimetry survey for the next few years. So what we have been trying to do over the past few years is modernize the systems, take all of those old telescopes and upgrade their operating systems to get them to be remotely operable. We have a remote observing room here in the main building. So if you go into the main library entrance to your right, you can see the remote observing room. So people can observe from here in Cape Town. They could observe from home or elsewhere as well if they've been trained. But it's also still possible to go to Sutherland and do observations from there. Some people prefer the traditional way. We used to have 1 week blocks of observing, and of course that doesn't suit everyone. Your target may only be visible for a few minutes every night. And so now it's possible to be much more flexible in the way we schedule observations. So we've now got the possibility of creating queues and fitting things into somebody else's run as needed. And this is all part of what we call the Intelligent Observatory program. So the last few years, there's been a lot of work done on the hardware side to modernize the telescopes. And now I think we're moving into the software phase, and we're really trying to make use of artificial intelligence to do things like come up with, or to monitor the telemetry of all the telescopes, the weather, and all of look at all the proposal and data information we have and do things intelligently, do preventative, alert us to do preventative maintenance and that kind of thing. So that project is led by Stephen Potter, who's our head of astronomy here. So here you can see the 1.9 meter Old Orange, as it's affectionately known. So it received a number of upgrades over the past few years to modernize. It now has an instrument selector port, so you can choose between instruments on the fly rather than having to do a whole changeover of instruments during the day. This project, as I mentioned, is moving into the software development phase. So we have an exciting collaboration with the UKRI's Hartree Centre, which is they're experts in artificial intelligence, and they'll be working with us to move into this new phase. So this is these are the PRIME and IRSF telescopes, which are Japanese partnerships. Minimize that. So you can see IRSF has been going since about 2000, I believe, and PRIME much more recent. But IRSF is also undergoing upgrades. And what we would like to do is help the partnerships to make both of these telescopes also remotely operable, to be operated from Japan or South Africa, and possibly join in with our new telescope control system, so that we can have this network of telescopes, including all of the telescopes on the plateau. So in terms of research at SAO, we have a few different research areas that we concentrate on. One of the big ones recently is transient and time domain astronomy. And David has been leading much of that with a large program on SALT to do follow-up spectroscopy of transient events. We have traditionally been very strong in stellar astronomy, do quite a lot of work on binaries of various masses, X-ray binaries, BE stars. And then we also have groups working on extragalactic astronomy, galaxy evolution, particularly looking at environmental effects that affect galaxies as they evolve. We have a few people working on active galactic nuclei as well. And that, I suppose, also fits into the time domain astronomy as well. And then we have a small group working on planetary science. Nick Erasmus and his team are looking at asteroids, characterizing asteroids, and they're very involved in the ATLAS collaboration. And see if this, my animation won't play because I'm in PDF, but that was supposed to show the DART impact, which we observed from Sutherland as well. So there are a few people working on exoplanets, and that is an area that we would like to grow. So I'm looking forward to hearing more about this field this week, and we're going to see how that progresses. I think particularly with the laser frequency comb coming onto HRS, this is an area that has a lot of potential for us. And we are doing research in astronomical instrumentation as well. So some of the areas in which we have strengths are CCD technologies. We have our fiber astrophotonic lab that's developed the new IFU units for the RSS on SALT. So we have a strong instrumentation division, and that's another area that we would like to see growing over the next few years. We have an excellent high precision machining workshop. So pieces like this, very complex pieces, can be made here on site. And we actually are one of the few places in South Africa where this can be done. So we provide parts for Ikwemba Labs, the accelerator lab, doing physics, producing radioisotopes for medical research. And we're also providing receivers for the SKA in future. Our student training, we've had a strong participation and partnership in the National Astrophysics and Space Science Program, NASP, which has been going for 20 years now. So I was one of the first students to come through NASP, and last year we celebrated the 20th anniversary. Many of our astronomers here lecture courses, both for NASP and other courses at universities across the country. And we also supervise a number of students. So from honors level, which is our 4th year here in South Africa, up to PhD level and postdocs. We usually have between 20 and 30 students supervised by astronomers at SAO every year. And we encourage our students to get involved in observations, to get involved in outreach and open nights. And I think actually our open nights wouldn't be possible without them. They really make a huge difference. So we have many different education programs. I think one of the important parts is that we train teachers to do the Earth and Beyond curriculum. So we do workshops with teachers across the whole country, and we also host learners coming from schools both here in Cape Town and in Sutherland. We have a job shadow program and participate in many different expos and sort of career guidance activities. We have our public tours and open nights, and hopefully during the course of the week you will get a chance to see our visitor centre here on site, and our museum, but our museum with some of the old instruments, and our lovely McLean telescope, which was built in 1896. And then we also have a visitor centre in Sutherland, and we regularly host tours there. Sutherland is one of the coldest places in the country, and one of the few places where you get snow. So people are actually very excited to go and visit Sutherland even in winter. Luckily, we won't have any of that this week, but I hope you'll enjoy the visit. We have what's called the SALT Collateral Benefits Program, which has been going since SALT started, to try and use some of the benefits of SALT to contribute to the community, in particular in Sutherland, which is a very poor community, but to develop the community. And Sutherland has grown, particularly with tourism becoming a destination as a result of SALT. So before SALT was built, it had about 2 guest houses. It now has more than 40. So there's been quite a change in the area as a result of SALT, and we consider it very important to keep giving back and contributing to the clinic in Sutherland, to the schools, and so on. The other important thing is that we host the Office of Astronomy for Development. So this is one of the International Astronomical Union's offices. Last year, we hosted the IAU's General Assembly, and this was the first time in Africa. And that was largely led by our staff based at the OAD, the Office of Astronomy for Development. So they do fantastic work coordinating projects around the world that look at how you can use astronomy to benefit people, to make the world a better place. So they, at the moment, the main sort of flagship areas that they're concentrating on are using astronomy to improve mental health, which some of us may not have thought of, but apparently is a possibility. Looking at how the skills that we develop in astronomy can be used to do other things outside of astronomy, skills transfer, and then looking at things like this astrotourism, where fairly remote communities can use the natural resource of the night sky to bring tourists in and develop economically. Then looking a little bit beyond SAO itself, I thought I'd just give you a brief overview of what the astronomy research landscape is in South Africa. We have our 2 national facilities of the National Research Foundation, ourselves, and the Radio Astronomy Observatory. And I mentioned already that SAREO is building the SKA. The Meerkat Radio Telescope has already been in operation since 2018. And then we have a number of universities that are and continues to grow. So Stellenbosch wasn't on this list until quite recently, but astronomy is continuing to develop in South Africa. So many universities in the Western Cape in particular, and in Gauteng, where Johannesburg and Pretoria are. And then there's an observatory in the Free State, Boyden Observatory. There's a sort of teaching observatory in Mafeking that's part of the Northwest University as well. And then the University of KwaZulu-Natal in Durban also has astronomy and cosmology research. So those are the main areas where astronomy is being done in South Africa. This is an image of the Meerkat Radio Telescope. So it's 64 dishes. The SKA is going to take that up to about 197 dishes, I believe. But they also have the Hartbrow 26-meter dish, which was built in the 1960s as a satellite tracking station for NASA. So those are run by the South African Radio Astronomy Observatory. And then we're very involved in the African Astronomical Society, or AFAS. We host the Secretariat of AFAS here on site, and you may meet Charles Takulana this week, who's been leading that. And we would like to really support astronomy across the continent. So the General Assembly last year was seen as an opportunity to really, help develop astronomy in South Africa. And the idea was that it wouldn't just be one event, but have a lasting legacy. And so part of what we do is also try to support observatories in other places. So I think David is probably our most experienced in visiting the observatories elsewhere in Africa and providing input to them. There's a high energy facility in Namibia called HES, which you can see here. This small telescope is also at the HES site, I believe, or just next door. And they're trying to resurrect the small telescope to use it for transients as well, to connect up with the network of other telescopes. Then there are also observatories in Ethiopia and Morocco and in Egypt. And we would like to collaborate with them and eventually integrate telescopes in all of those places together into an intelligent network that can follow up transients, choosing the most appropriate instrument for any particular event. We have workshops and training sessions on SALT, how to propose for SALT time, how to do the data reduction for SALT. And so we'd like to encourage astronomers across Africa to really make use of SALT. They all have access to SALT through the South African partnership. And then we participate and teach at various schools across Africa. Some recently in Botswana and Kenya through the DARA program, but also PASEA further north. And so that's it from me, an overview of SAO and what we do here in South Africa. I hope that you'll have a very good week and enjoy the visit to Sutherland on Friday. And feel free to ask me if you have any questions about any of this that we do here at SAO. Thanks.
Okay, well, thank you very much, Rosalind. And if there are any questions, now's the time. Please wait for the microphone to get to you, otherwise the folks on Zoom can't hear.
As far as I understand, the SALT telescope is mostly used for spectroscopy, right? Are there any perspective to also to improve it for the high resolution imaging with instruments such as NACO or VLT, where they're very important instruments for the direct detection of planets? Are there any perspective to doing the same with SALT?
Yeah. So unfortunately, is this on? There we go. Unfortunately, the seeing in Sutherland is not great. David, again, is probably the most experienced in looking into whether some kind of adaptive optics could be used on SALT. There has been some research into it, but I believe the conclusion is that it's not really going to help or not really going to work. So we try and take advantage of what we do have, which is particularly the dark sky, and do spectroscopy rather than imaging. We do have, the high speed imaging modes, and we'd like to improve that. So that you can do, time series photometry and that kind of thing with it. But we're unlikely to go to higher resolution imaging.
Just a reminder to the folks online, you can post questions in the chat. Anybody else have a question in the room? If not, I would like to ask more about the Intelligent Observatory system. Now, you mentioned that you were using AI to actually measure the telemetry for the observatory itself and look for preventative maintenance, which is a brilliant idea and a huge amount of work for the observatory staff otherwise. Are you also looking at using it to schedule observations?
Yes, I think that was the original idea, and choosing which of the suite of instruments and telescopes available is the best one to follow up on a particular event. So, and also to characterize, so using machine learning and all that. So there are, I think, a few different sort of branches to the project. Some of them are more operational, but then also the scientific side of it, characterization and yeah, the choice of instruments is definitely a big part of it.
Expanding that to telescopes across Africa would be incredibly powerful.
Yes,
That's a
so
fascinating project.
yeah, I mean, we in this sort of time zone, I think South Africa's observatories play a very important role in completing the observations around the 24 hours. But there would be others further north in Africa that could reach further north. So it would be very advantageous to try and combine them.